Hello.
Hi.
Were you able to print out the quiz?
Yes.
How about you, Brian?
Yes, ma'am.
All righty. Any questions so far? I got you going, not with the swivel thing, but with the my computer, so that if you need help on any of them, I can share my screen and do the whiteboard and show you on that.
Oh, okay.
Okay, so just let me know if you have any questions on any of them in particular. I'm going to go hand it out to the girls.
I have questions, but that's on the homework.
Oh, on the homework. Okay, I can do it.
Lucy started yet?
What?
Have you started?
Yeah, I'm on number 6.
Oh, shoot. Okay.
I just copied it.
What a legend.
You're supposed to.
That one out already? Oh, yeah. Guys, did y'all have a question on the homework from yesterday?
No.
4-5, okay, Ava did, so I'm gonna work on that with her. If I move away from the computer, you won't be able to hear me as well, so if you wanna hear something over again, just let me know.
Okay.
Which one, Ava?
25B. I was trying to find it and I just.
Yeah, this one was weird, I was kind of a little bit in class yesterday. That might have been hard to follow. Okay, so you got A then, right?
Yeah, we have A. And then you gotta get the first derivative of it.
Right. And so you have theta equals, and the thing is that they're using X and T. So that's kind of what. It's 100. And so this is X, and so they want to find D delta dx. And so there you had D is the derivative, inverse tan, and over 1 plus, and then instead of putting X here for X squared, you put X over 100, right? And then times the derivative of X over 100, which is the same thing as, like that. And so this is just the derivative, just 1 over 100. Okay. So you can rewrite that. I don't know how far you simplified it. If this isn't parentheses, you have 100 times 1 plus X squared over, and I'm just going to do this as 100 squared. Okay. And then if you distribute this, you'll get 1 over 100 plus X squared, and then this 100 would cancel one of these 100. Right here, so you have just X squared over 100. And then the back of the book didn't like to have that fraction in the fraction. And so they went on and did some more stuff to it, but you can just do it like that.
Okay, because I got that, but it was really, like, I looked at the back of the book and it was.
10,000 and all that.
Yeah.
You can just do it like that. Okay, and then the second part then was use a chain rule to write an equation for d theta dt. Okay, so this is d theta dx. And so they want d theta dt. Okay, and so, no, so when I say use the chain rule, that's where you multiply two things together and cross things out to get this. Okay, so I'll show you. So if you have d theta dx, which we already have, and you want to get d theta dt, you need to get the dx to cancel out. So we're going to put dx up here and dt here. Okay, so this would cancel. Okay, so d theta equals d theta dt equals d theta dx over dx dt. Okay, so this is what they want, and you can even substitute the d theta dx that we have 100 plus x squared over 100, and then times dx dt. Now the picture that we have, you have the triangle in the book, and you know the truck is right here. And then this right here is x, is distance, here is x. And so dx dt is the distance divided by the time, which is the velocity, right? And so this is the velocity. And that's what they're going to want us to find. Okay. So this is B. You're done with B when you have all of this, right? And you have to get this. Well, I had to get this.
You can't simplify that into the middle of negative dx over dt.
No, because what we're going to do is we're going to find that. Because what they're going to do is they're going to tell us, actually, go check that. And they're going to give us a value for d theta dt and ask us how fast is the truck going. They're going to give us a value for this and ask us to find that. Okay. So we'll just leave it like this for speed. So you could actually, if you wanted to get dx dt by itself, all you have to do is multiply by the reciprocal, which means you have d theta over dt. I moved it over on this side of the line, plus the reciprocal, or times the reciprocal of this, which is the reciprocal is 100 plus x squared over 100. That makes sense. First of all, I switched these, so I have dx dt myself over here. And then to get it away from the dx dt, I'm going to talk about the reciprocal of it, which means just the denominator at the top. Okay. Does that make sense? Not really. We don't even have to do it that way. So let me do something more concrete then.
It's trying to understand, like, when I see derivative and antiderivative and second derivative, I get that.
Mhm.
But as soon as they start using the symbols like dx and dt and d theta, I'm like,
Right, yeah. And so I guess it probably helps to, like this is theta right here, right? And so when they say, and this is x, so as x is getting shorter, well then theta is going to get smaller, right?
yes.
Okay, so d theta dx is the rate at which theta is getting smaller as x changes. Okay, and then d theta dt is how much this is changing as time goes by. Okay, not as the distance gets smaller, but as time goes by. Okay, in order to find that, you can do this d theta dx and dx dt because this is x, so the velocity is dx dt. So you can multiply them to figure out what d theta dt is. Okay, but then they tell you what d theta dt is. It says when at x equals 100. No, 500. Theta is changing at a rate of, and then they say d theta dt is negative. Apparently he's slowing down because he saw the top. 0.04 radians per second. Okay. And then how fast is the truck going? And so dx dt is question mark. Okay. And all this happens when x is 500. Okay, so what we're going to do is we're going to take this and plug stuff in from here, plug it in. And so d theta dt is negative 0.04. And then we got 1 over 0.100, and then plus, and then x is 500. That's right there. So we're going to put 500 squared over 100. And then times dx dt is what we're looking for. And so all I got to do is figure out what this number turns out to be, and then say this divided by that. And then that'll be in feet per second. Then they want you to get it in miles per hour, and you could use the app on the calculator to find to do that conversion if you want. Okay, how y'all doing? Smacking. Just a check. Yeah. Are you doing Right. So that's the chain rule. And so you put the 3 down in front. Okay, you're forgetting to leave the inside the same. You're getting ahead of yourself on that. Okay, so now leave cotangent. OT, yeah. Squared of just 5x. So you're following that. Because you do the derivative of the power rule. You use the power rule by putting the 3 down in front and making it squared, but you leave the inside the same 5x. And then now you multiply by the cotangent, the derivative of cotangent. But it's 5x. So you're using that. And then times the derivative of 5x. Right.
You can't put those.
Well, yeah, you can probably multiply the 5 times the 3 and then move the negative out in front. And then that's the tangent squared of 5x. Tangent squared. Okay, so you can put this, since you're multiplying by it, you basically can put it in the numerator, right? And so you have, you make this round in case. Let's see any other. What number is that?
Christmas number 11.
11. Here. Oh, okay. And it was, so you had,
It was natural log of x to 1.7.
right, okay. And so now, you know that you're gonna have 1 over x to the 1.7, and then times the derivative of x to 1.7. That's where you put the 1.7 in front and then x, and you subtracted 1 and just hit 0.7. Okay, so you can write that where the 1.7 x to the 0.7 is over x to the 1.7. But this can be simplified. You know what the rule is?
Is it the unity?
No, because you're not doing derivative. You just, like if I have x to the a over x to the b, that's gonna be x to the what? Remember what to do. If you had x to the a times x to the b, that would be x to the a plus b.
So it would be a minus.
Right, a minus b. And so you can simplify all of that for 1.7 x to the 0.7 minus 1.7. And then that is, yeah. Which you could also write as 1.7 over x if you wanted to. Same thing. X before and this is natural Okay, yeah, and then all of that being multiplied by x squared. And then 2x like that. So looks like you get factor of x, both of these terms, and then cancel it with one of the x's down here. Yeah, yeah, x. No. Well, you could, after, just looking at the numerator, you could factor 2 to the x. Let's go ahead and do that. 2 to the x and x. This is what happens. So that x up there is going to cancel on that. You know what, you probably, since you factor these things out of both of these, and you probably have, again, what I would do is in parentheses that x natural log 2 minus x. I put that x in front of the natural log 2, so you don't need the parentheses for those two. X natural log 2 minus 2. Yeah. Well, that makes it right. Yeah. Oh, let me do that one on the board too, because I'm just thinking. You started good. You did the first step. Okay, so the outside function was the power, you know, the function. The inside, the first inside is cotangent, so you need to multiply it by the derivative of cotangent, which is negative, yeah. Derivative of 5x minus x, 5x. And then finally times the derivative of 5x. Right. And then just multiply all together.
So I can put this.
Get 15, and then even negative of 5. Okay, so 2x. I'm going to do it on the board. And this was number 12. Okay. So I copied it right, correct? Okay. And so u equals 2 to the x, so here u prime equals 2 to the x. Okay. on. Can y'all see that okay?
Mhm.
And Maddie, that's what you ended up with, right? I think.
Yeah.
Yeah. So you just had to get your U prime, V, and V prime, set it all up. And then I just factored a 2 to the X and an X out of both of these. And then I canceled one of the X's. With your U and U prime and V and V prime.
Wait, why did the X to the fourth go X
To the 3, because up here, I factored an X out because there was X squared in this term, an X squared, and in this term there was an X.
I see.
Yeah. It's just the quotient rule and factoring, nothing else. Okay, so, oh, that looks good. Okay, so this is the first derivative. So the second derivative is gonna do derivative of all of this. Okay, so this 3 is like a constant multiplier. Like I would, like if y prime was.
But if it doesn't have an X, so it can just.
No. E to the 3x without the original? Okay, and so y prime is 3 e to the 3x. You just have the 3 out on this side. I'll put it like that. Okay. And so to do a second derivative, you bring the constant multiplier down, and then you say the derivative of that is going to be 3 e to the 3x, just like it was a minute ago.
Oh, okay. I see.
And then you can multiply. Catherine, do you want I want to reverse to you.
Yeah. I'm supposed to get these, it starts out like ratings per second,
Mhm.
and then this is feet right here. So I was just to get
Feet per second. Did you not get feet per second?
I put that because I know there's
I'm
gonna
gonna
be that
put you know it's
answer,
gonna be
but
there.
I want to understand.
Okay, well, radian is a pseudo unit. I mean, you don't actually write it. Like usually if they say radian per second, you can just write it as per second.
Okay.
Yeah. And so,
It's just understanding.
okay, dxdt was feet per second.
Mhm.
And you ended up, okay, well, you just need that, right? Okay, so how did you get it? So this was radians per second, and this over here, the tangent. And all that we knew on that one was that the 500 was the distance, right? They said at 500 feet. And so we had no unit and then over 100, I don't know if we need it there, plus 500, and that's feet squared. Actually, if you square it, right? And then you flip it to multiply by this guy. So that's this in feet squared per second.
As long as I know that matters, really matter,
Yeah, right, other things don't matter.
and that makes sense to me. Now what was the active one that we chose with the company?
Okay, so we go to app. We go down to, side tools or. And then you're gonna go meet and then look. You don't really need a negative, that just means you're going down. So put in 104 and go up here, yeah, go feet per second, hit enter. And it's gonna go to, and then go to what you want, which is either just 91 miles per hour, right? And hit enter. And it gives it kind of a notation, so you get it anywhere. Means instead of 7 point, it's 70 point. I got 71 minutes. Up and out, 31 miles an hour. Okay, 15. Okay, and so then you get all of that. Right. Oh, so you're. There you have an x4, and there you have an x2. And you have a sign. Let me write this down and then. Okay, and then after that, it's cosine. I just want to make sure it wasn't sine and cosine. This is being multiplied by that. Okay. Okay, so you got these two terms, and you can think about it like this. You have 4 and then x, and this is 3 sine x's. Sine x, sine x, sine x. Just being real blatant about it. Okay, and then we have 4 x's, x, and a 3, and then 2 sine x's, and cosine x. Okay, and so there's 2 sine x's here and 2 sine x's there, and there's 3 x's there and 3 x's there. So that looks like all they have in common. And so I'm going to take the 2 sine x's, I'm just going to write them as sine squared x. Oh, I guess x cubed, I'll put that up here, like that. And so I'm taking that out and that out. That's going to leave 4 sine x plus, and that, I'll have 3x cosine x. Really on that, I'm not sure that it's all that critical to factor it out. I'm just wondering, what was the rest of the thing? Okay, and so then you plug 2 in. Into that. Into this, yeah. That's going to be a sine of 2 squared. And 4 sine of 2 plus 3 times 2 is going to be 6. So sine of 2. And then on the other one, you're going to have E, hang on a minute. You did the sine of 2 squared, but it's the sine of 2, the whole thing squared, not just 2 squared, but sine of 2 squared. And so you have to put sine of 2 in parentheses. Kind of what I did here. Put sine of 2 in parentheses.
Oh, I see. And then, yeah, like that.
Yes.
Okay.
And then times 8, right? Because you had 2 cubed. Oh, that's gonna be, you have to add, make sure you add these two together before you multiply them by that. You can just type that whole thing in. That was 492. Oh, there's a 2 here. I don't know where this X came from.
It came from this one, from this derivative process.
Right, but you have an X there. That's what I did.
Oh, you put it there.
I just moved it on the other side of the 3.
So I
So
don't need this too.
if that's just 6 cosine 2.
That's negative.
You did it. 36. Oh, okay. So then you go to your second alpha window, right? Your alpha window. Then you go to derivative. You get your home screen. You put X there. You put the original function there.
Because I did that in my graph.
Oh, so you could say, before, fine. Yeah, so you could put Y1. Oh, but I wouldn't graph it. You don't really want to graph it. Go back to your home screen real quick. And you can put Y1 there. You could edit in Y1. And then put 2 there. Because that's going to evaluate the derivative of 2, and you got the same thing.
And then on the paper, do I need to say anything special?
Maybe you say the same answer. Yeah. Okay, so did you get to, oh, you did. So you did right. Yeah, that's what you got. Okay, so then, now you want to, it tells you to compare it to finding it numerically by your grapher. So you do alpha window. You go down to inderivative. Okay, put X there. And then you want to put the whole original function. What's that? That. Okay, X to the 4th. And then you probably want to do parentheses, sign X, and then parentheses cubed.
Oh, sorry.
X. And then close your parentheses.
Thank you.
Yeah. And then go out. Yeah, that, and then put a 2 there, because you want to evaluate it at 2. Well, you know what? Okay, go back and switch the places of that you delete that. And delete again, okay, and then go out. Yeah, let's do that, yeah, because that should work. And you can put
Okay, so
then you can write the same on
oh,
graph, on your calculator. Yeah. Right. Exactly. I don't know who did it, but women. You can roll a cosine. So it's like having a cosine down here, but you can because the tangent is sine over cosine. So cosine times gamma times the cosine or cosine. No, I think you'll end up with just sine squared down here and that's it. The peak in here is going to cancel with the cosine down here. They have those, Pythagorean properties that sometimes these things squared when you put them together equals one, but when you have a two in front of it, it's not gonna work. So you just do it like that.
Okay, so just, is it the same square then, or just?
Nine squared. Yeah. Okay. Can you get any questions? I'm trying to talk to you all.
She's so for this one, I'm sure just for this thing.
Yeah, so just write how we say it is, oh, this is a quotient, so just write what the quotient rule is in terms of,
And then also for this one, if you're not going to have to
you don't have to use, yeah, you write tangent and sine over cosine, and then you use your quotient rule and simplify it to get to these words. Simplifying is what's tricky.
you said the first thing, and then you find it.
So they're saying, how do you find the derivative? What is the quotient rule? They just want you to write the quotient rule, this right here.
That's
That's
it,
it.
so I add the divided.
No, they're just saying that, see, this is y prime, you could put dy dx there,
Okay.
and it's still the same thing.
So,
Oh, that's good. Yeah.
we have to,
Uh-huh.
like, and then I put the rest here, so how do you,
Okay, so just clear that out. Do you want to go to your,
this one?
no, keep white one there, since you've already, yeah, but just clear white for that. Yeah, and then go to your home. Okay, then do, alpha one, derivative, yeah. And now you can put x there and y1 there, since you have it in there. And then here put 2. You want to evaluate it at 2, and you get to get an answer. And this thing.
That's not a lot of fun. So,
Any questions with you guys?
I have some.
Okay, what you got? I'll tell you what, I'm going to share the screen, but tell me what you got first. Which ones?
I have a question on 9 and then 15.
Okay.
And for 9, I just not sure how to simplify it once I get the.
Okay, what'd you get so far? Like, what do you need to simplify?
I got 2 e to the 2x times cosine cubed x minus e to the 2x
Okay.
times 3 sine cubed x. I mean, no, sorry, 3x.
Okay.
And yeah, the cosine cubed x is also a cosine 3x. That's my bad. The
Okay.
first one I told you, yeah.
So like that?
Yes.
You could factor an e to the 2x out, but I don't know how useful that would be. So I would take it either way.
Oh, okay.
Other than that, I don't think there's anything else you can do. And normally I would put the 3 in front, just like you have the 2 in front over here. That's just preference. That's not anything.
Okay.
So that's all for that one?
Yes.
Okay, which one is 15? What does it say?
That is the use the product rule to find f prime of x if f of x is x to the 4th sine cubed x, and then
Yeah.
show the f prime of 2.
Okay, I have that one on the board currently, so I'm gonna roll you over here. So you can see it. Have to roll that far, maybe not. Probably not. Unless I take it out of that. That's gonna be hard. Can you read this very well?
Mostly.
So I've got the original, no, I've got, oh, this is what you get when you do the product rule. Did you get that far? It's 4x cubed sine cubed x plus x to the fourth, 3 sine squared x cosine x.
Wait, where do you get the cosine x at the end from?
Plus u, okay, all of this is v prime. Because first you take the derivative of the sign, like the power rule, you put a 3 down in front and put a 2 there, but you leave the sign the same, the inside's the same. And then you have to multiply by the derivative of the inside, which is the derivative of sine.
Oh, okay.
Did
That's
that make
probably
sense?
the problem.
Yeah. And then I went through some factoring to get this.
Okay. And so you just like pull stuff out and then simplify from there?
Yeah. And actually, if you didn't want to simplify, I mean, you don't even have to really factor that out if you don't want to. You could probably leave it like this up here.
Mm-hmm.
But then you have to figure out what is it when x is 2. So down here, I plug 2 into this form, and you end up with like 7.54. So whether you plug 2 into this form or this form, you should get the same number.
Okay.
And then you're going to go to your home screen and alpha window, and you have to put in the little x here, then you have to put this in, and you have to put the little 2 here.
Okay. And then you should get the same thing?
Yeah, you should get the same thing.
Okay.
Oh, yeah.
So this one cancel out and then this will come back.
Oh, it's minus.
And then because it's a negative sign.
Oh, this plus, yeah. Yeah. Oh, okay. So what did you do? Did you just cancel it? Where did this go?
This, because I canceled those.
No,
and
you
then
can't
you
cancel that. No. That's what they call freshman canceling. That's actually a thing. Maybe freshmen are supposed to do it.
Okay.
Okay, so at this point, you can let it here, because you're supposed to remember the pre-cal off the back of your hand and say, oh, 5 squared, cosine squared, that's just equals 1. Get 1 over cosine squared, and somebody just left. I can't believe it. They just hung up on me. Nope, they're still there. Oh, Ian Mills is trying to join. Okay, so I've got to switch over to chemistry, so do y'all mind if I, wait, is it already time? I watch it.
We have small groups right now, so.
We have small groups, so what's Ian doing? Yeah, so I'm just gonna cancel him, okay. And it's 9:56, y'all get out at
55.
5, okay, yeah, okay. Well then, we're gonna continue working on this tomorrow. We may start something else if you finish everything, but no rush. I'll talk to you later then. We're gonna work on it some more tomorrow. I know Maddie's already finished, but